to be if such an event had actually produced our universe. The answer they got was that the Big Bang explosion had to be precisely tuned to within 1 part in 10 to the 60th power. That's a 1 with 60 zeros after it. Here's an illustration of this. As you probably know, the planets, stars, and galaxies of our universe are made of atoms. If a Big Bang event actually created our universe, then it created about 10 to the 80th power atoms. If this creation event had to be finely tuned to within 10 to the 60th power, then the number of atoms could only have varied by 10 to the 20th power. That's about the same number of atoms contained in a single grain of sand. The calculation showed that the Big Bang model couldn't tolerate any variation more than this. If a Big Bang had actually happened, but it had created just the tiniest additional bit of matter, if it had created just 1 extra grain of sand than what's currently in our universe, then we wouldn't be here, because our universe would have collapsed into a black hole long ago. On the other hand, if the Big Bang had created a universe with just the tiniest bit less matter, if it had created just 1 grain of sand less, then the universe would be completely empty today, because space would have expanded too quickly and galaxies could never have formed. Either way, if the alleged Big Bang had produced 1 grain of sand more or 1 grain of sand less, we wouldn't be here. We couldn't be here. In other words, the idea that a Big Bang created our entire universe, the idea that a random event could be so precisely finely tuned down to a single grain of sand is ridiculous. But believe it or not, when cosmologists added dark energy to the Big Bang model a few years later, the fine-tuning got even worse. Far worse, in fact. It turns out that dark energy also has to be finely tuned to 1 part in 10 to the 123rd power. Now we've gone from ridiculous to silly. As cosmologists have admitted, our universe appears surprisingly fine-tuned for life, in the sense that if you tweaked many of our constants of nature by just a tiny amount, life as we know it would be impossible. Some of the fine-tuning appears extreme enough to be quite embarrassing. For example, we need to tune the dark energy to about 123 decimal places to make habitable galaxies. Now we're talking about fine-tuning that's far less than a grain of sand. If there are 10 to the 80th power atoms in the universe, and the Big Bang's dark energy has to be finely tuned to 10 to the 123rd power, then the Big Bang's precision must be a tiny fraction of the average atom in the universe, just 10 to the minus 43rd power. In other words, the precision required for the Big Bang is now far less than a grain of sand. It's far less than 1 atom within a grain of sand, or 1/10 of an atom, or 1/100th of an atom. No, the required precision is this ridiculously tiny fraction of the mass energy contained within a single atom. That's how precisely fine-tuned the alleged Big Bang had to be. For scientists who want to deny a creator, finely tuned dark energy discredits a random Big Bang so thoroughly that one described it as a cataclysm for physicists. We've seen that even according to the Big Bang model, the universe looks exceptionally fine-tuned. How do secular cosmologists explain this? Actually, they don't have one explanation. They think they have an infinite number of explanations, thanks to something called the multiverse. The multiverse means multiple universes, the idea that our universe is not the only universe that exists. Now this probably sounds strange because how can there be more than one universe? After all, the word universe means all that there is. Well, cosmologists have redefined the word. The word universe now refers to that part of reality that we could ever perceive. So other universes refers to regions in physical reality that are beyond our observation, not just now, but ever, even with the best conceivable telescopes and so on. The collection of all these universes is called the multiverse. Today, countless cosmological articles and papers have been written, and continue to be written, about the multiverse. Although the early versions of the Big Bang model didn't include this concept, today's Big Bang model does say that there are infinitely many universes out there beyond our perception. It might sound weird, but this is mainstream today within the cosmology community. This is a key point, because in just a moment, we're going to see that the multiverse idea creates tremendous problems for the Big Bang model's claim to be scientific. But sometimes when you point this out to people, they'll claim that the multiverse isn't part of the Big Bang model. So let me emphasize again. It's true that the original Big Bang model didn't include a multiverse, but that's changed. Today's Big Bang model does produce a multiverse, and for more than one reason. For example, most cosmologists today believe that the cosmos has zero curvature and is infinite. This leads directly to a multiverse, because there would be an infinite number of universes we'd never be able to see. As we discussed earlier, most cosmologists also believe in inflation. It's an important part of the Big Bang model today. The original idea of inflation said that the universe inflated for a short time and then stopped, which supposedly formed our early universe. But cosmologists have realized that once inflation begins, it goes on eternally, spawning an infinite number of universes as it goes. This goes on forever. Inflation will produce an infinite number of universes because it can never stop. As cosmologist Alan Guth pointed out, eternal inflation is the almost unavoidable consequence of our best understanding of the fundamental laws of physics. And as another cosmologist has said, garden-variety inflationary models yield a gargantuan number of bubble universes carved into an eternally expanding spatial expanse. The existence of an inflationary multiverse would be an inevitable consequence. The multiverse is now well established within cosmology, and even in popular science books. In fact, it's big business now. If you need some extra money, just write a book about all the universes out there that nobody can ever see. After all, who can prove you wrong? Anyway, most secular cosmologists are actually happy that the Big Bang predicts a multiverse, because they think it allows them to escape the fine-tuning problem. After all, if the multiverse contains an infinite number of universes, then it doesn't matter that our universe is extremely fine-tuned and appears to be well-designed and is outlandishly unlikely to have formed in a random Big Bang, because in an infinite number of universes, even the most unlikely universe will exist somewhere. And according to most secular cosmologists, we just happen to live in such an unlikely universe. As two cosmologists commented, this picture of the universe, or multiverse as it is called, explains the long-standing mystery of why the constants of nature appear to be fine-tuned for the emergence of life. The reason is that intelligent observers exist only in those rare bubbles in which, by pure chance, the constants happen to be just right for life to evolve. The rest of the multiverse remains barren, but no one is there to complain about that. Call it a fluke, a mystery, a miracle, or call it the biggest problem in physics. Short of invoking a benevolent creator, many physicists see only one possible explanation. Our universe may be but one of perhaps infinitely many universes in an inconceivably vast multiverse. Most of those universes are barren, but some, like ours, have conditions suitable for life. The idea is controversial. Critics say it doesn't even qualify as a scientific theory, because the existence of other universes cannot be proved or disproved. Advocates argue that, like it or not, the multiverse may well be the only viable, non-religious explanation for what is often called a fine-tuning problem, the baffling observation that the laws of the universe seem custom-tailored to favor the emergence of life. But even though this idea is popular among secular scientists, is it actually good science? Let's think about this. First, look at this sentence in the article. Critics say it doesn't even qualify as a scientific theory, because the existence of other universes cannot be proved or disproved. That's a correct statement. By definition, all the other universes outside of our own would be unobservable. Therefore, there's no experiment or observation you could perform that would either confirm or disprove this idea. In other words, the multiverse is not a theory that's open to scientific investigation. It's just an item of faith. Plus, think about the implications of the multiverse. If we live in an infinite ocean of universes, then there's an infinite number of universes that are almost exactly like the one that you're in now. As one cosmologist explained, in the far reaches of an infinite cosmos, there's a galaxy that looks just like the Milky Way, with a solar system that's the spitting image of ours, with a planet that's a dead ringer for Earth, with a house that's indistinguishable from yours, inhabited by someone who looks just like you, who is right now reading this very book or watching this very video. And there's not just one such copy. In an infinite universe, there are infinitely many. If the cosmos is infinitely large, it is home to infinitely many parallel worlds. Another wrote, "Is there another copy of you reading this article? A person living on a planet called Earth, with misty mountains, fertile fields, and sprawling cities. You probably find this idea strange and implausible. Yet it looks like we will just have to live with it, since the simplest and most popular cosmological model today predicts that this person actually exists in a distant galaxy. Your alter ego is simply a prediction of the so-called concordance model of cosmology, which is used as the basis for most calculations and simulations presented at cosmology conferences. If space is infinite, and the distribution of matter is sufficiently uniform, then even the most unlikely events must take place somewhere. In particular, there are infinitely many other inhabited planets, including not just one but infinitely many, with people with the same appearance, name, and memories as you. Indeed, there are infinitely many other regions the size of our observable universe where every possible cosmic history is played out. If we live in an infinite multiverse, then there are an infinite number of universes, and everything that's possible has occurred somewhere. There's a universe where you are watching this video, and everything else is exactly the same as in this universe, except that you had something different for breakfast this morning. There's an infinite number of universes where the South won the American Civil War. There's an infinite number of universes where there never was a civil war because the original 13 colonies lost their revolution against King George III, and so on. In a multiverse, even the most unlikely events must take place somewhere. Remember this phrase, because this idea has very important consequences, as we'll see later. And also remember that this is the mainstream view within cosmology now. As an article in New Scientist said, our most successful theories lead to the inescapable conclusion that our universe is just a speck in a vast sea of universes. The multiverse is not some kind of optional thing, like can you supersize or not, says this theoretical physicist at the University of California in Berkeley. Our own cosmological history, he says, tells us that it's there and we need to deal with it. So remember, regardless of how weird the multiverse may sound, secular cosmologists demand that it's true, and you just need to deal with it. But what they aren't telling you is that the multiverse is devastating to their claims that they're actually doing science at all. We'll talk more about this in just a moment. And that brings us to the end of this section. In the first part of this video, we saw why the Big Bang model is claimed to be good science. In this section, we saw that it's not such good science after all. Everything cannot have come from nothing. The claim that it did violates the most fundamental principles of physics. Also, some cosmologists who claim that everything came from nothing don't really believe that there was nothing before the Big Bang. They actually believe that there was something rather than nothing. But they have no explanation for where this something came from, or how it could sit there for an eternity, or why it would suddenly decide to turn into a universe for no reason. The Big Bang has several fatal problems, which secular cosmologists tried to solve by invoking a short period of inflation early in the Big Bang. But the particle that supposedly caused this, called the inflaton, is completely hypothetical. It's completely unknown to physics. So in order to rescue the Big Bang from its problems, cosmologists are invoking things that are outside of science. Cosmologists also have no way to stop inflation once it starts. Once begun, inflation is an eternal process and produces an infinite number of universes. The Big Bang model requires the universe to be filled with cold dark matter, but the model has no explanation for what cold dark matter might be, or how it came to exist. Other observations indicate that if the Big Bang model is true, then the universe must be filled with some mysterious anti-gravity stuff that secular cosmologists call dark energy. But again, the Big Bang has no explanation for what dark energy might be, or how it came to exist. Cosmologists claim that the Big Bang model explains everything. But even if it were a good model, which it isn't, it would still only explain 5% of everything, which means 95% of the mass energy of the universe is unexplained by the model. The cosmic microwave background is claimed to be good evidence for the Big Bang, but recent measurements of it are causing large problems for the model instead. The Big Bang model requires an extreme amount of fine-tuning, not only in the Big Bang itself, but also in many areas of physics. This is deeply embarrassing to secular scientists who want to deny a creator. The Big Bang model also predicts a multiverse, containing an infinite number of universes, which among other things means there are infinite other copies of you spread throughout the cosmos. This supposedly avoids the fine-tuning problem, but all these other universes would be beyond our perception, so there's no way to investigate this idea to see if it's true. This means that this idea is outside of science. Well, that's quite a list, isn't it? But the problems with the Big Bang model actually go far deeper even than these listed here. We've already seen that the Big Bang model isn't good science. But it also turns out that when you really dig into it, it's not even bad science. the Big Bang model is actually anti-science, because when you take the model to its logical conclusions, it makes science itself impossible. Let's talk about that now. For this section, I said I'd give you a reason why the Big Bang model is anti-scientific. I'm actually not going to give you one reason. I'm going to give you 5 reasons why the Big Bang is explicitly contrary to the most fundamental principles of science. Here they are. The model violates the laws of physics. The model denies the laws of physics. The model is self-contradictory. The model has absurd implications. The model refutes itself. Let's talk about these in order. Reason number 1. The Big Bang model violates the laws of physics. We've already seen that the Big Bang model violates some of the most important principles of physics, like the conservation of mass and energy. Any model which claims to be scientific, while violating the most fundamental laws in science, isn't actually scientific. That's pretty straightforward. Reason number 2 is a bit more subtle. The Big Bang contradicts the laws of physics in an even deeper way than just violating them. Here's a question. What's the most basic, the most fundamental thing you need in order to do physics? You might think the answer is laboratory equipment, or maybe the scientific method. Or something even more basic would be our senses, so we can make observations of the world around us. But there's something more basic even than all of these. The most basic thing you need in order to do physics is a universe to which physics can be applied. And the Big Bang model can't supply this. Earlier we discussed how the Big Bang model says that time didn't exist before the Big Bang occurred. The Big Bang is supposedly the very first event in history. That's why cosmologists frequently make comments like this one. If space spontaneously popped into existence, so did time. Namely, time and space are both classical concepts that may have a limited domain of validity. And so, the question what was before the Big Bang may simply be a bad question, because there was no before. Time didn't exist. Think about what this means. It means that the Big Bang had no cause, because a cause has to come before its effect. And before the Big Bang, there was no time in which a cause could have occurred. As one astronomer explained, maybe there was no ultimate cause for the universe. It just happened. And another cosmologist famously said, the universe is simply one of those things that happens from time to time. Well, if the universe just happened, if there was no reason for it to create itself, if the universe's self-creation was a random event, then the universe was founded in randomness. It would inherently be a random thing. But science requires that the universe operate consistently and non-randomly. Science requires that the universe operate according to strict laws of physics, so that we can perform experiments to discover those laws and understand how the universe works. Science requires the universe to operate according to consistent patterns of behavior, so we can test and explore and eventually discover those patterns. But according to secular cosmologists, the universe was founded in randomness. So, do these cosmologists have the right then to expect the universe to operate according to strict laws of physics afterwards? No, they don't. It would seem instead that a universe which began in randomness would stay random. Now, scientists who approach science biblically don't have this problem. The Bible says that our Creator is a God of order. He upholds the universe by the word of His power. Unless He intervenes in the form of a miracle, the creation works according to consistent laws. Not only that, He has promised that the creation will continue to operate according to regular and predictable patterns. So scientists who believe in the Bible can trust that there are laws of physics, and that science is therefore possible. But secular cosmologists deny that there is a creator who made an orderly universe. They insist that everything came from randomness, for no reason whatsoever. But if everything is random, which is what the Big Bang model implies, then science becomes impossible. Therefore, secular cosmologists have no reason to expect science to work. Am I saying that someone who isn't a Christian can't do science? No, I'm not. In fact, there are many good scientists who are secular and don't believe in a creator. But they aren't doing science while acting consistently with their secular beliefs, because that would be impossible. Instead, they're basically borrowing from the Christian worldview and assuming that the universe is orderly despite the implications of the Big Bang model. As one physicist has pointed out, people take it for granted that the physical world is both ordered and intelligible. The underlying order in nature, the laws of physics, are simply accepted as given, as brute facts. Nobody asks where they come from. At least they don't in polite company. However, even the most atheistic scientist accepts as an act of faith the existence of a law-like order in nature that is at least in part comprehensible to us. So science can proceed only if the scientist adopts an essentially theological worldview. Reason 3. The Big Bang model is self-contradictory. Think about the multiverse idea for a moment. Remember, it's part of the Big Bang model, and it's there, and we need to deal with it. But even secular cosmologists admit that the subject of parallel universes is highly speculative. No experiment or observation has established that any version of the idea is realized in nature. The multiverse says there's an infinite number of universes outside of our own. By definition, all the other universes can't be perceived. They're unobservable. What word do we use to describe things that are outside of our observable universe? If they're outside of the universe we can see, then they're outside of the natural world, which means they're supernatural. That's what the word means, right? Outside of nature, beyond nature. But earlier we saw that the Bible was rejected as a possible explanation for the universe because it offers a supernatural explanation. Here we see that the Big Bang model is doing the same thing. In fact, do you remember that definition of science we saw at the beginning of this video? Modern science does not deal with supernatural explanations because they are not scientifically testable. In other words, there's no way to gather evidence that would help us determine whether or not the explanations are accurate. Well, that description perfectly matches the multiverse. By definition, all the other universes can't be detected. And since the Big Bang model requires a multiverse, this means that the Big Bang model ultimately isn't scientific. Even some secular thinkers agree with this. These multiverse theories all share the same fundamental defect. They can be neither confirmed nor falsified. Hence, they don't deserve to be called scientific. Multiverse theories aren't theories. They're science fictions, theologies, works of the imagination unconstrained by evidence. Another said, "My own moral concerns about the multiverse have more to do with worry that pseudoscience is being heavily promoted to the public. If a wrong idea is promoted for enough years, it gets into the textbooks and becomes part of the conventional wisdom about how the world works. This process is now well underway with multiverse pseudoscience." After the initial period of creation, the biblical account of origins is consistent with both the laws of science and the practice of science, but the Big Bang model is not. Instead, the Big Bang model denies supernatural explanations, while at the same time, it requires supernatural explanations. Its claims to be science are self-contradictory. Reason 4. The Big Bang model has absurd implications. In Matthew 7:20, Jesus said, "By their fruits ye shall know them." If the Big Bang were a good model, then its fruits would be good science. But if it's not a good model, then its fruits will be wrong, or perhaps even absurd. So let's examine the fruits of the Big Bang theory and of secular cosmology overall. And for each item we'll ask, is this actually good science? Or is it just science fiction? We'll start with the fine-tuning of the universe. We saw earlier that cosmologists are wrestling with this and trying to deny the creator that this fine-tuning implies. Some have said that the universe is fine-tuned because we cause it to be that way, just by looking at it. As an article in New Scientist explained, maybe we should approach cosmic fine-tuning not as a problem, but as a clue. Perhaps it is evidence that we somehow endow the universe with certain features by the mere act of observation. It's an idea that Stephen Hawking has been thinking about too. Hawking advocates what he calls top-down cosmology, in which observers are creating the universe and its entire history right now. If we in some sense create the universe, it's not surprising that the universe is well suited to us. In other words, the universe doesn't really exist on its own. We create it just by looking at it, so of course it would be fine-tuned for us, because we're the ones creating it. That's an amazing story. But is it science, or just science fiction? Meanwhile, some other cosmologists don't like the idea that the universe had a beginning, because even though the Big Bang model isn't biblical, the idea that the cosmos had a beginning still sounds too much like the book of Genesis. So they're trying to get rid of it by saying that our universe doesn't really have only 3 spatial dimensions. It's actually a multidimensional membrane universe that periodically collides with other multidimensional membrane universes, and each collision creates a new Big Bang in a regular cycle that goes on forever. Of course, none of these other membrane universes are observable to us. Is this science? Or just science fiction? Other cosmologists are trying to get rid of a beginning by getting rid of time itself. For example, one wrote, "Our universe may be the offspring of some other universe. Baby universes fluctuate into existence in both directions of time, eventually emptying out and giving birth to babies of their own. On ultra-large scales, such a multiverse would look statistically symmetric with respect to time. Both the past and the future would feature new universes fluctuating into life and proliferating without bound. Each of them would experience an arrow of time, but half would have an arrow that was reversed with respect to that in the others." In other words, there's an infinitely large multiverse, filled with an infinite number of big bangs, producing an infinite number of baby universes, none of which we can see. And oh, by the way, in half of those universes, time must flow backwards. Is this science? Or science fiction? And while we're talking about the multiverse, we saw earlier that Big Bang believers try to explain away many of their problems with this idea. But a multiverse has implications that are just silly. For example, in a multiverse, there's an infinite number of planets out there with alien life, including an infinite number of planets full of dinosaurs which didn't go extinct like they did on Earth, but continued to evolve instead. Well, what would that imply? One secular scientist, who wasn't writing about the multiverse specifically, still touched on this idea when he warned, "Such life forms could well be advanced versions of dinosaurs. We would be better off not meeting them." Yes, we would be better off not meeting them, because there's nothing worse than meeting up with a dinosaur that has better